So they give us in the problem that the balloon is rising at a constant rate of 3 meters per second. So that means that here's the balloon going up. So that's y. So dy over dt is equal to 3 meters per second. For A, and this 100 is a constant, it doesn't change, so we can label it as 100. If this is rising, x is changing, and theta is also changing. So that's why those are labeled with variables. A, we want to find the rate of change in x when y is 50. So I'm just going to redraw the triangle, and this stays 100. I'm going to change y to 50, which means I can go ahead and find x using Pythagorean theorem. So that would come out to be, if you do a squared plus b squared, 100 squared plus 50 squared equals c squared. C comes out to be, what, 50 root 5? You can also leave it as the square root of, what is that, 2 or 1, 2, 5, 0, 0. You can leave it like that if you want, or you can change it to, or you can simplify the radical. All right, so then how are we going to find dx over dt? That is going to be an equation that involves x, y, and 100. So we're going to do Pythagorean theorem. So x squared is our c, sorry. C, x squared is your hypotenuse. So it would be 100 squared plus y squared equals x squared. So there's our equation, and then we're going to find the rate of change. So this 100 squared is a constant, so the derivative of that is 0. The rate of change in y squared is 2y times the rate of change in y equals 2x times the rate of change in x. And then we can go ahead and plug in. So 2 when y is 50, so we're going to put in 50. dy over dt is, that was given up here, is 3. And 2x is that 50 root 5 that we found from Pythagorean theorem. And we are trying to find dx over dt. So dx over dt is equal to, I don't multiply it out because I'm just going to end up canceling. So you can cancel the 2's, you can cancel the 50's. So dx over dt comes out to be 3 over root 5. You can leave it like that, or you can say that it's 3 root 5 over 3. And then the units is meters per second. Okay, so that is part A. Part B, they want us to find the rate of change in area of the right triangle. So the area of a triangle is 1/2 base times height. So in our picture, the base is 100 and the height is y. So I'm going to change this area formula to be 1/2 100 times y, which is the same thing as 50y. Then I'm going to find the rate of change. So dA over dt is equal to 50 times dy over dt. And remember that was given. So dA over dt is equal to 50 times 3, which is 150. And remember, area would be measured in meters squared per second. So that is the answer to B. And then C is asking for the rate of change in theta. So for C, they want us to find d theta over dt when y is 50. So we already found over here when y was 50, x was 50 root 5. So now we need an equation that involves theta. And then I also want, so we need to involve theta. I want to use the 100. And because they gave us dy over dt here, I'm going to also use y. So when I look at that, I have opposite over adjacent, which is tangent. So tangent of theta is opposite over adjacent. So that's the equation I'm going to use. So I'm going to come down here. So I'm going to have tangent of theta equals opposite, which was y, over adjacent, which is 100. So again, opposite was y, adjacent is 100. And then I always like to rewrite this as a fraction of 1 over 100y. Just makes finding the derivative a little bit easier. So the derivative of tangent is secant squared theta times the rate of change in theta. The derivative of 1 over 100y is 1 over 100 times the rate of change in y. And so now we're going to be plugging in for secant theta squared. We're looking for d theta over dt and dy over dt. Sorry, I'm running out of space here. So we have to go back to this when here, which is this picture. So theta is right here. So secant, remember, is the reciprocal of cosine. So when I look at this picture, cosine of theta is adjacent over hypotenuse. And I can reduce that, but so secant would be the reciprocal of that. So when I go, let's go ahead and reduce that. Sorry, I'm running out of space here. So if cosine of theta is equal to 100 over 50 root 5, I can change that to 2 over root 5. So that means secant would be root 5 over 2. So when I come over here, I'm going to put in root 5 over 2 squared times d theta over dt equals 1 over 100, and dy over dt was 3. So when I square that, I get 5/4 times d theta over dt equals 3 over 100. So d theta over dt is equal to, we multiply by 4/5 and 4/5. So 12 over, oh, we can reduce that. We can reduce 4 goes into 125 times. So what's that? 3 over 125. And in calculus, that is, angles are measured in radians per second because it's the rate of change in the theta.